Hey everyone, and welcome. Today we're diving into something really cool, the Great Indian Climate Puzzle. India's climate is just this incredible story of extremes. And you know what? We're about to piece it all together. Let's get right into it.
So here's the big question that gets us started. How on earth can one single country have blistering hot deserts and literally the wettest place on the entire planet? Not to mention tropical beaches and peaks that are frozen solid. It's an amazing puzzle, right? Well, by the end of this, you're going to have all the pieces to solve it.
And I'm not exaggerating about the extremes. Just look at these numbers. We've got Dras and Kargil plunging to a mind-numbing minus 40 degrees Celsius in winter, while Jaisalmer is baking at 50 degrees. And the rain? Mawsynram gets soaked with almost 12,000 millimeters a year. Jaisalmer? Just over 200. These places are practically on different planets.
So, how are we going to solve this puzzle? Simple. Here's our game plan. First, we'll expose the 6 main controllers that dictate India's climate. Then we'll do a deep dive into the star of the show, the monsoon. After that, we'll walk through the 4 seasons, and we'll wrap it all up with a handy cheat sheet to help you absolutely crush your exams. Sound good? Let's go! Okay, first things first, the 6 controllers. The best way to think about these is as the master rule makers. They're the ones behind the scenes calling all the shots when it comes to India's weather. If you understand them, you understand everything. And here they are, our 6 rule makers. The Himalayas, latitude, altitude, the seas around India, relief features, and of course, the monsoon winds. Let's break them down one by one.
First up, the big one, the Himalayas. You have to think of these mountains as a giant climate bodyguard for the whole country. They form this massive wall that physically blocks the freezing, icy winds that try to sweep down from Central Asia. Honestly, without them, winter in northern India would be unbelievably harsh. They're a total game changer.
Next up is latitude. You see that imaginary line, the Tropic of Cancer? It cuts right through the middle of India, basically splitting the country into 2 climate zones. Everything south of that line is in the tropical zone. It's hot, it's humid, and temperatures don't change much all year. But north of the line, that's the subtropical zone, where you get those really distinct hot summers and chilly winters.
Controller number 3 is altitude, and this one is super simple. The rule is, the higher you go, the colder it gets. For roughly every 166 meters you climb, the temperature drops by 1 degree Celsius. It's a fundamental law of climate, and it's why you can escape to cool hill stations like Shimla when the plains below are just scorching hot.
Okay, number 4, the seas. India isn't landlocked. It's a giant peninsula with water on 3 sides. And this water has a huge cooling and warming effect called a maritime influence. It stops the coast from getting crazy hot in summer or crazy cold in winter. And, maybe most importantly, all that water is the fuel source, the moisture for the monsoon.
Relief features, that's just a fancy term for the mountains and hills inside the country, like the Western Ghats. Now these are like traffic cops for rain. When the monsoon winds, full of moisture, come in from the sea, the Western Ghats block them. The wind is forced to go up, it cools down, and boom, it dumps all its rain on one side. The other side, the rain shadow side, stays pretty dry.
And that brings us to our final controller, the star player, the monsoon winds. These are more than just winds. They are the absolute engine of India's climate. They're the reason for the seasons, the bringer of rain, and the lifeblood for millions of farmers. They are, quite simply, the ultimate rain delivery system.
So now that we've met all the rule makers, it's time to put the spotlight on the most important one of all. Let's really get into the nitty-gritty of how the Great Indian Monsoon actually works. This is what truly defines the climate of the entire subcontinent.
So what is a monsoon? A lot of people think monsoon just means rain, but that's not quite right. It's actually a wind system. Specifically, it's a complete 180-degree seasonal reversal of winds. In summer, the winds blow from the sea to the land, carrying tons of moisture. And in the winter, they flip and blow from the land out to the sea.
And how does that happen? Well, it's all about air pressure. Wind always blows from high pressure to low pressure areas. In the summer, the Indian landmass gets super hot, creating a massive low-pressure zone. The ocean is cooler, so it's a high-pressure zone. Naturally, the moist winds from the sea rush in to fill that gap. That's your summer monsoon. In winter, it's the exact opposite. The land is cooler, so it's high pressure, and the dry winds blow out towards the warmer, low-pressure sea. Okay, you get it. We've got the controllers, we've got the monsoon mechanism.
Now let's put it all together and see how this amazing story unfolds over the course of a year. Let's take a journey through India's 4 distinct seasons.
So here's the annual cycle. It starts with a hot, dry summer from March to May. That's followed by the main event, the southwest monsoon, from June to September. Then we get a transition period called the retreating monsoon, and we finish off with a cool, dry winter, which is also called the northeast monsoon.
The summer is basically the warm-up act. The whole country heats up, which sets the stage for the low-pressure system that will pull in the monsoon. This season also gives us some pretty famous local winds. You've probably heard of the Lu, those hot, dry winds in the north. Down south, you get mango showers, perfect for helping mangoes ripen. And in the east, Kalabaisaki brings thunderstorms that are absolutely vital for tea crops.
And then the main event arrives. Usually around June, you get the burst of the monsoon. It comes in like a two-pronged attack. One branch, from the Arabian Sea, smacks into the west coast, soaking places like Mumbai. The other branch, from the Bay of Bengal, sweeps up into the northeast, drenching Monsoon, before it hooks a left and moves west across the northern plains.
After months of rain from October to November, the monsoon starts to pack its bags and leave. But this transition creates a really weird weather phenomenon called October heat. The skies are clear, so it's hot, but the ground is still wet, so it's super humid. It's just oppressive. This is also the time when powerful cyclones can form in the Bay of Bengal and hit the southeastern coast.
And finally, from December to February, winter sets in. For most of India, this means cool, dry, and really pleasant weather. But there's one really important thing that happens: western disturbances. These are weak storm systems that travel all the way from the Mediterranean Sea. They don't bring a lot of rain, but the little bit they do bring to North India is absolutely crucial for winter crops like wheat.
Phew, we have covered a lot. So, to make sure all the most important stuff really sticks in your brain, here it is, your final exam cheat sheet. This is the stuff you absolutely, positively need to know.
You will almost certainly see a question about this on your exam. This table shows how the rain is distributed. And look, it's not random. The heavy rainfall areas are right where the mountains block the winds, the Western Ghats and the Northeast. And the scanty or very low rainfall areas? They're in the rain shadow, like Rajasthan, or they're a cold desert far from the sea, like Ladakh. It all connects back to those 6 controllers.
All right, pop quiz time. Let's see if you were paying attention. Go ahead and pause here and try to answer these 3 questions. Okay, you ready? Number 1. Mumbai gets way more rain than Pune because of the rain shadow effect. Mumbai is on the windward side of the Western Ghats, Pune is on the other side. Number 2. Western disturbances are crucial because they bring winter rain for Rabi crops. And, number 3, October heat is caused by that nasty mix of high temperatures and high humidity when the monsoon is leaving. How'd you do?
And let's end with one final thought. We've just spent this whole time piecing together the puzzle of India's climate, a pattern that's been in place for centuries. But now, with our climate changing, that ancient pattern is becoming less predictable. So the real question, the puzzle for your generation to solve is this: how is the story of India's monsoon going to change in your lifetime? Think about it.